Surface area of cylinders. This is the lecture for the notes on this, so these are the notes that you should have. Again, if you don't have access to a printer and you can't print these notes out from the website, from Google Classroom, just grab a sheet of paper, get ready to write some things down. When I go over the examples, I would write the examples down. Just kind of, put as much as you can down on the paper so that you have it for later to help you with the worksheets that I put up to go along with this. And then that way you'll be more successful with the quiz too. Okay, so we need to know what a cylinder is here and what shapes can a cylinder be broken up into. And then number two, how do you find the surface area of a cylinder? Okay, so starting off with definition here for a cylinder. So a cylinder is a special type of prism that has circular bases. Okay, and with those circular bases, they would then, along each side, we'll have parallel sides. Okay, so again, the idea, if I take a piece of paper here, roll it on itself, here I've created a cylinder, so circle on top and bottom are the bases, and then my sides all run parallel to one another, and that's what creates our cylinder. The surface area of a cylinder is made up of two circles, right, for the bases, so a circle on each side for the base, top and bottom, and a lateral surface between the two bases. Okay, now last week we talked about lateral surface area on the lateral sides of the prisms and the pyramids that we were looking at. So these also have, the cylinders have a lateral surface as well. We don't necessarily call it a lateral side because, again, it's a circular, so it doesn't really have sides per se to it, but it's rather just a lateral surface here. What's unique, though, about that lateral surface is, if I go back to my paper example I had a second ago, again, if I take this paper, roll it on itself, it makes a cylinder. But if I think about what the lateral surface actually is, well, it's the paper, right? So if I open it up, what shape or figure do I actually have here? Well, I've got a rectangle. So the lateral surface here is really just a rectangle. And you can kind of see that down here, right? I've got my three-dimensional cylinder. If I unroll the lateral surface, it makes a rectangle, and then I have my two circles for the top and bottom of the cylinder that make up the bases. Now, when it comes to our lateral surface, you'll notice this red line is going to match the line around the outside of the circle. And so the length in our rectangle here, that red line that goes around the outside, remember we call that the circumference of the circle then. So the circumference of the circle makes up the length of our rectangle, that is our lateral surface. The width then, you can see here, is shown with h, and that is from the height of our cylinder. Okay, so when it comes to looking at the overall surface area, what we really have here is we have two circles that make up the bases on either side, and then we have this rectangle. And so coming up with the surface area for that, we need to combine all of those. So as it says next here, finding the surface area of a cylinder. Once again, we're going to add up all of the sides, or all of the surfaces, the areas of those surfaces that we have. In that case, the area of two circles. And remember, for area of a circle, we have to do pi times the radius squared, or pi r squared. So we're going to need to have to know the radius on the of our circle on each of the bases. Because it is a cylinder, they'll be the same on each side, though. And then we know the area of the rectangle for the surface area is length times width. Okay? But in this case, again, if we think about what the length and width are, so again, that length is actually the circumference of the circular base that we started with. So again, if it's circumference, then remember to find the circumference, that's going to be equal to 2 times pi times the radius, or we could do pi times diameter. So either one of those would calculate that. And then what the width is, remember, is really going to be the height of the cylinder. So putting it all together then, the total surface area, we have pi r squared from our circles for the bases. But remember, we have two of those. So we have two circular bases. And because we have two circular bases, we're going to have to multiply that by 2. And then we have the area of our lateral surface, which again is rectangular in shape. But that's going to be 2 pi r for the circumference, because that's what the length is going to be made up as. And then multiply all of that by the width of the rectangle, but again, that's the height of the cylinder. Okay, so if I wanted to simplify that a little further, 2 pi r squared plus 2 pi r h, okay, for the overall surface area of a cylinder then. So again, this part makes up the bases, and this part makes up the lateral surface. Okay. So before we get to the examples, a couple column questions over here to answer. So identify the measure of each of the following from the cylinder. So in this cylinder, it's laid on its side. So the lateral surface this time goes around this way. Our bases are actually on the left and right side of it, but there they are, our circular sides. So here we have a measurement of 4 inches and a measurement of 9 inches. You'll notice the measurement of 4 inches is measuring from the center of the circle out to the edge. Again, we do call that the radius, so that's going to give me this answer here. If I did want to or need to use the diameter, remember that's going to be extending it all the way across because the diameter goes all the way across the circle, passing through the center. But that's twice the radius. So 2 times the 4 inches there would give us 8 inches for the diameter. And then our height this time, again, it's called height still, but really it's kind of across the length of our cylinder, but still going to be considered the height of the cylinder, and that'll be 9 inches here. Okay, so just wanted to make sure we knew how to label a cylinder and where we were looking to find the radius and diameter and where we're looking to find the height. Because sometimes our cylinders will be oriented this way, sometimes they'll be like they were over here in this example, and this is actually the same here. But if you notice, the line across the top this time, going through the center of the circle, is all the way across. And so, which measurement is that? That's the diameter. So 14 meters this time for my diameter. If I wanted to go back and go to radius, then the radius would be half of that, right? So halfway across. So that's 7 meters across there. And then this time the height over here on the lateral surface, 2 meters being shown for the height. Okay. Okay, turning the page then, a couple of examples. So finding the surface area of these cylinders. So again, maybe write it over here in the column. To find S, again, we have to combine 2 parts. So we're going to do 2 times pi times r squared plus 2 times pi times r times the height. Okay, for again our bases portion and our lateral surface part of things. Okay, so on this one, measuring up top up here is shown by the red line halfway across the circle. So again, that's called the radius, so that's r. The 7 feet that's being shown here is measuring the height of the cylinder. So there's my radius and my height. And again, as you can see, those are the 2 things that I need to be able to make my calculation. So S is going to be equal to 2 times, remember we use 3.14 for pi in our calculations, times the radius, which is 6, squared, plus 2 times pi again, 3.14, times the radius, which is 6, times the height, which is 7. Okay, grabbing my calculator here, multiply this first part of things together. So 2, show how I'm putting this in, times 3.14 times 6 squared. Okay, and if I see what that gives me, 226.08. Looking up at the directions, it does say to round to the nearest tenth here, just like it is in the homework. So practicing doing that, 226.0 is in the tens place. The 8 would tell it to round up. So I'll do 226.1 plus, now the other part is 2 times 3.14 times 6 times 7. And so putting all of that in, we get 263.76. The 7, again, is in the tens place. The 6 would tell it to round up, so 263.8. Okay, adding those together. We get a total of 489.9. That's already to the tens place, so the second 9 is in the tens place, so I don't have to do any rounding on that one. The number's good where it's at. It was measured in feet, and once again, this is surface area, which is an area measurement, so we're going to put squared on our units there. Okay, number 2, again, follow the same process. Draw a line to divide here, so we don't mix our work up. So surface area is equal to, okay, looking at things up here, this time this 6 that's across the circle, the base side of things here, the line goes all the way across, so this is the diameter. For my calculation, though, I want the radius, so we'll take half of that. That means the radius here is going to be 3 centimeters to use in our calculation. And this time, even though it's laid on its side, the height of my cylinder across the lateral surface there is 12 centimeters. So 2 times 3.14 times 3 squared plus 2 times 3.14 times 3 times 12. Almost ran out of room there. Okay, 2 times 3.14 times 3 squared is 56.52, so round that to 56.5, plus 2 times 3.14 times 3 times 12, and 226.08, so round the 0 up to a 1, 226.1. Okay, adding those two numbers together, get a total of 282.6 measured in centimeters, square it because of area, so 282.6 centimeters squared. Okay, going down to the column question here. Excuse me, not column question, conclusions. So number 1 says how much paper is used to create the label for this can of peas then. And so if we think about it, the label just wraps around the lateral surface. And so really what we're finding is just the lateral surface area here. And so to do that, we just need from our equation, it's just the second part of things. So we just need the 2 pi r times h portion of that. So it would be 2 times pi, 3.14, times our radius, which is being given here, it's 1 inch, times our height of our cylinder is 2 inches. Okay, and multiplying that out, 2 times 3.14 times 2 basically gives us 12.56. Doesn't specify to round here. If you did round to the nearest tenth, you would round the 5 up to a 6, but if I leave it as 12.56, it would be inches squared, because it's, again, an area measurement, but that's how much paper we would need, 12.56 square inches of paper for the label of the can. Okay, number 2, an error analysis problem. So find and describe the mistake made in finding the surface area of the following cylinder. So we've got a cylinder that has a radius of 5 yards, a height of 10.6 yards, and they have S is equal to pi r squared plus 2 pi r h is equal to pi times 5 squared plus 2 pi times 5 times 10.6. All right, well, hopefully at this point you're already noticing what the mistake is. They use just pi r squared instead of 2 pi r squared. Just using just pi r squared would give you just the area of one of these circles, but since we have a circle on top and bottom here for our surface area, again, we have to multiply that by 2 in there. So okay, so need to multiply the pi r squared by 2 because there are 2 circular bases. So the proper calculation would be 2 times pi, but if I use my 3.14 for that, times 5 squared plus 2 times pi times 5 for the radius times 10.6 for the height. Okay, putting it all together. You are actually able to put the whole thing in the calculator once the calculator knows how to use PEMDAS properly here. Just sometimes make less mistakes by chunking it up a little bit. But looks like it comes out to be 489.8 yards squared for the proper calculation there. Okay, and then lastly, the summary. So, a cylinder is a 3D prism that has circular or circle bases on each end. The side of the cylinder is called the lateral surface, and if laid flat, it forms a rectangle. The rectangle has a length that is equal to the circumference of the circle or circular base, and a width that is equal to the height of the circle, or excuse me, of the cylinder. The surface area then can be found by adding together the area of each circle that makes up the bases and the area of the rectangle that makes up the lateral face or lateral surface. The formula for finding the surface area of a cylinder is, so again, S is equal to, again we need 2 times pi times the radius squared plus 2 times pi times the radius times the height. Okay, so hopefully that sets you up to be successful now with the worksheet on the surface area of cylinders. If you have questions, find me on Google Hangouts. Probably doing a live Google Meet on Wednesday. So if you have questions about this and you want to get those answered, that'd be a good time for that. But you can reach out to me by email or through Google Hangouts at any time during the week, and I'll get back to you as soon as I can. Okay, good luck with things.